So in this lesson, we're going to be talking about factoring polynomials, and we're going to determine how we can figure out the zeros or the roots of them by factoring. So specifically, we're looking at this part of our standard, and we're going to make sure we know how to determine the roots of a polynomial by factoring. Okay, so first we're going to start off with a review. Difference of squares. We've already talked about this when we talked about factoring quadratics. But just as a reminder, we're looking at numbers like 1, 4, 9, 16, 25, 36, 49, etc. Okay, remember the rule is that when you're subtracting two terms that are perfect squares, it's always the square root plus the square root times the square root minus the square root. Let's look at number 5. So on number 5, I always want to look for a GCF first. So I see that both terms are divisible by 7, both terms are divisible by an m, and both terms are divisible by n. So that gives me m to the 6th minus 4n squared. Now you might look at this and you'll be like, okay, well, that doesn't look like a perfect square, my Shannon, because that's not squared. Well, it is. What we're looking at here is, what did I square that would give me m to the 6th? Well, I squared m cubed, because remember, 3 times 2 is 6. And this one's pretty easy to figure out. So I have my GCF. Square root of m to the 6th is m cubed. Square root of 4n squared is 2n plus, and then because it's a difference of squares, it's the same thing all over again. Okay? So this is what we call quadratic-like factors. Okay? Let's go over one more that's similar to that. So if I look at number 6, common factor is 10w. And what am I left with? W to the 4th minus 1. W to the 4th, remember, I'm thinking to myself, what did I square to get w to the 4th? That would be w squared, because 2 times 2 makes 4. And 1 is a perfect square of 1. So this would be w squared plus 1 times w squared minus 1. So here's another rule. Okay, this one works with perfect cubes. And remember, perfect cubes are numbers like 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, etc. Okay, the rule goes, and this one is for the sum. It says, if you had 2 perfect cubes being added together, it always factors like this. The cube root plus the cube root, and then square minus the product of the cube roots plus the square of the cube root. Okay, so let's look at number 7. That's a review. So what did I cube to get x cubed? I got cubed an x. What did I cube to get 27? I got a 3. And now I square the x. Subtraction sign is next. The product of x and 3. Square of 3. Okay, let's go ahead and look at number 9. So what's the common factor of 504? It's 4. So if I go ahead and factor out a 4, I get 125, a cubed plus 1. 125 is a perfect cube. It's a perfect cube of 5. 5a plus 1, 5a squared. Then we have the product with a minus sign in front of it plus the square of 1. Now, why does this one also work? Well, if we go ahead and take out the common factor, and in this case, it would be a 3, a c, and a d, we get 8c cubed plus 125 t cubed. And that's why it's a sum of cubes. So we have 3cd, cube root of 8 is 2, cube root of c cubed is c, plus cube root of 125, cube root of d cubed, and now it's square 2c, subtraction, multiply, and square 5d. Okay, now we're looking at difference of cubes. So it's actually the same rule. Not much other to learn other than the signs change. Starts off with, we'll recognize it because there's a minus sign in between the perfect cubes. And it starts off with cube root minus cube root, square of the cube root. And now the signs are all going to be pluses. Okay, let's go ahead and look at number 12. So 216 is 6 cubed. And we already know 5 cubed is 125. So cube root of 216 would be 6. Cube root of k is k. Cube root of 125 is 5. Because of the minus sign, I put a minus. Everything else is a plus. Square 6 and k. Multiply 5 and 6k, ignoring the sign. Square the 5. Okay, and finally, we're going to be looking at trinomials that have a GCF or are what we call quadratic-like trinomials. So they factor the same way as we did with trinomials. So first, remember, you always go ahead and you look for a common factor, like on number 17. Everything is divisible by 2, and everything is divisible by a. And so what do I have left? I have a squared plus 19a plus 34. So I'm looking for two numbers that multiply to 34 that add up to 19, and I know that they both have to be the same sign. So that would be 2a, a plus 17, a plus 2. Okay, let's look at number 15. It's a little bit different. So this is a fourth degree polynomial. However, it fits a pattern of a quadratic-like because there's something that I squared to get n to the fourth, and that would be n squared. So if I think to my brain, so I'm thinking that this is similar to n squared plus 2n minus 24. And I know that would factor as n minus 4 times n plus 6, because negative 4 times 6 makes negative 24, and negative 4n plus 6n makes 2n. But that n value isn't worth an n, it's worth n squared. And if I went ahead and multiplied that out, I would get n to the fourth plus 2n squared minus 24. And now there's one more thing I can go ahead and I can do to factor this completely. Because especially when we have higher degrees, sometimes it's possible to factor further. So what I notice is that this, n squared minus 4, is a difference of squares. So I got to take that and I have to multiply it out by, factor it out. N plus 2 times n minus 2, square root plus square root minus square root, and n squared plus 6 is not factorable. So now it's completely factored. Okay, and finally, let's go ahead and go over one like number 20. Okay, so I see it's not quadratic, it's to the fourth power. So these quadratic-like comes up when we have two terms or three terms, and we have first the degree of the polynomial is even. So I know that m squared squared gives me m to the fourth. So in my brain, I'm thinking this is like 9m squared minus 12m plus 4. And if I go ahead and I factor that out, I would think about it as I need two numbers that multiply to positive 36 that add up to negative 12. And that would be 6, negative 6, and negative 6. So if I go ahead and I did my box, I have 9m to the fourth, positive 4, negative 6m squared, negative 6m squared. Okay, so now we're going to do common factors. So common factor this way, 3m squared. Common factor this way, 3m squared. Common factor this way would be 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 3m s be a negative 2. Going and doing the rows, positive 3m squared, and again negative 2, negative 2. So what do we have? We have 3m squared minus 2 times 3m squared minus 2, which is the same thing twice. So I would write it 3m squared minus 2 squared. Okay, and finally, I might have said that already, we have factoring by grouping. So this is when you have an even number of terms, and we want to go ahead and factor it because I can't find a pattern for it. So what we do is we split it in half, right straight down the middle, and we look at each half like as a separate problem for a moment. So what's the common factor of x cubed and x squared? It would be x squared. What does it leave behind? Well, x squared times x gives me x cubed, and x squared times 1 gives me x squared. When we factor the second half, always look to see what the sign of the leading coefficient is there. If it's a negative, always factor out a negative, and then look for the common factor in the two terms. So in this case, they both are divisible by 4. And when I do negative 4x divided by negative 4, I get 1x. And negative 4 divided by negative 4 is a positive 1. So the next thing is we take out the common binomial, x plus 1, and then we group what's left over, x squared minus 4. And hopefully you recognize this is not fully factored because x squared minus 4 is a difference of squares. So to finish factoring it, we would do x plus 1, and then factor x squared minus 4 as x plus 2 times x minus 2. Okay, let's go ahead and try that one more time. Okay, let's look at number 23. Okay, so I split it in half. 4 and 5 have no common factor other than 1, but v squared and v cubed have a common factor of v squared. So when I take out v squared, I get 4v minus 5. On the left, leading coefficient's negative, so I take out a negative. And 16 and 20 are both divisible by 4, leaving me 4v minus 5. So now I rewrite. I go ahead and I take out my common binomial and group what's left over and look to see if I can factor any more. In this case, v squared minus 4 is a difference of squares. That is not always going to happen, but always double check. And there we have it. Okay, now let's say that we were asked to go ahead and say that this was equal to 0 and we were solving an equation. Well, the next step is, remember, to take each factor, set it equal to 0, and solve for x. I add 5, divide by 4, gives me 5/4. This is one solution or root. V plus 2 equals 0, gives me v is negative 2. That's my second one. V minus 2 equals 0, gives me v equals 2, and that's my third. So that's how we use factoring to solve polynomials.